Hello everyone, welcome to Bodhi Academy. Let's start with the PYQ series of subject chemistry, chapter electrochemistry. Let's begin with the first question. What's the question? Draw a neat label diagram for the following representation of a galvanic cell. Okay, so they have given the represented the cell. The cell they have given magnesium and Mg2 plus concentration of that solution and Ag2 plus and concentration of that solution and Ag. And they have told us to calculate the EMF of the cell. Okay, they have given us E0 cell, everything has been given. E0 cell is given, concentration of the two solutions are given. Okay, let's see, go through this. First we'll see the diagram and then we'll come to the problem. Okay, so this is the question. Now we'll start. The diagram is what? Galvanic cell. Galvanic cell, what it is? Magnesium. They have given us the cell representation which is mentioned in the question, magnesium and Ag. Okay, so accordingly this is the electrode, magnesium electrode which is immersed in the magnesium sulfate solution which is having this concentration 0.130 molar. Okay, and this is the silver electrode which is immersed in the silver chloride with solution. Silver solution, this is magnesium solution, and this is your salt bridge. So this is the diagram for that. Okay, you know what is the role of a salt bridge? It helps in the transportation of the ions and also maintains electrical neutrality. Okay, yeah, this is what is the diagram. These are electrodes. Yes, and which solution is present in this particular salt bridge is your saturated KCl solution. Okay, now let's move on with the solution, means the problem. In the problem they have given us the E0 cell which is 3.17. E0 cell is already given. Okay, which is, see, E0 cell is equals to 3.17 volt. Okay. So the first I have written the half reactions, and we know at anode oxidation takes place and at the cathode reduction takes place. So this is the half cell reaction. Oxidation means what? Loss of electrons, and reduction means what? Gain of electrons. Right. So this is the half cell reaction, and you are getting, so these two electrons get cancelled. So this is the overall reaction. Okay. They have told us to calculate what? The E cell. E cell I have been told. E cell means EMF. Okay. E cell they have told us to calculate. Okay. So this is the formula to calculate the E cell. E cell equals to E0 cell minus 0.0592 divided by 2 into log of concentration of your anode divided by your cathode. Okay. Then, so concentration of both the solutions have been already given. Okay, you just have to substitute the values. Okay, this, when you solve this, you will get 0.0295. Okay, this is 3.17. Then again further I have solved. Okay, into, when you solve this log, this I will explain. Log of this number divided by this number. What? This is of the type log of m upon n. It is of that type. Okay, so log of m, concentration of this, minus log of this. When you solve this, find the log of that, you will get, and subtract it, minus, no? Find the log of this, subtract this, find the log of this. After doing all that, you will get this answer. Okay, right, so done. So that's how. So you solve all this, then 3.17 minus, multiply this, whatever answer you are getting with this, approximate this answer you will get after solving this log, you will get this answer approximately. Okay, then minus this, then you will get your final answer is 2.96 volt. So 2.96 also approximate answer you will get, but close to this. Okay, then so while solving you will get the EMF. EMF is 2.96 volt and log after solving 7.113. Okay, that's it. Okay, let's start with the next question. The question they have asked: draw a neat label diagram of a dry cell. Calculate the equilibrium constant of the following cell. The cell representation they have given, it is same as the previous problem. Okay, magnesium, this cell. Okay, we'll discuss about it later. First, diagram. This is the diagram of a dry cell. Okay, the important parts have been already labeled. Okay, here this middle rod, it is your graphite rod, which is acting as a cathode. Okay, and the zinc container, inside this there is a other container inside, that is a zinc container, that is acting as a anode. Okay, in every cell there will be a cathode and anode. Okay, this is a brass cap and other things, paste of, here outside is a paste of MnO2 plus carbon, and here there is also a paste of NH4Cl and ZnCl2. Okay, okay, so this is the diagram for the dry cell. Okay, so based on that, after that they have asked us this problem. What they have given the temperature, which is 25 degrees, which I have converted into Kelvin, and Faraday's constant, which is 96500 Coulomb. Okay, and this is the same reaction. I have not shown the half cell reactions because it is same as the previous problems. So this is the overall reaction. Okay, and then E naught cell equals to E naught of cathode minus E naught of anode. E naught cell you have to calculate. Cathode and anode have been already given values of that, Mg and Ag. This is your anode, which is undergoing oxidation. This is your cathode, which is undergoing reduction. Okay, so you will get 3.17 volt, same as the previous one. E naught cell equals to, we have to find what equilibrium constant they have told us to calculate the equilibrium constant. This is the formula. Okay, Kc is your equilibrium constant which you have to find. Okay, so this is the formula. E naught cell is equals to RT upon NF ln Kc. N is the number of electrons, F is your Faraday's constant, R is your gas constant, which is 8.314, and temperature. Okay, all the things you just have to substitute. Okay, this I'm just shown. Solve by the whichever way you are convenient, solve in that way. You will get this answer, 246.06, and Kc equals to E raised to the power, means you are converting this log, no? It is log of Kc, ln of Kc, ln is a natural log, ln of Kc, so Kc is equals to E to the power, is of that type. You have to convert that, okay, to the exponent, then you get this. Once you solve this, you will get Kc equals to 1.09 into 10 raised to the power 107. Okay, yeah, that's all. Okay, let's start with the next question. Question number 3. What is the question? Draw a neat label diagram of Lagrange cell. Calculate the EMF of following cell at 298 Kelvin. Okay, so the cell representation is given in the question, and also the E naught cell, E naught value of cathode and anode, that is your nickel and magnesium is given. Okay, which is of nickel is minus 0.25 volt and magnesium is minus 2.37 volt. Okay, this is all is given in the question. First, they have asked for the diagram of Lagrange cell. That we'll see. So this is the diagram of Lagrange cell. Okay, there is a anode and cathode. Anode is a zinc electrode over here. Okay, and cathode is a carbon rod. Inside there is a thin rod, that is a carbon rod, which is a cathode, and it is covered by a porous pot. Okay, in which there is a mixture of MnO2 and charcoal. Okay, and this side, here there is a solution which is NH4Cl, ammonium chloride and sodium paste, the solution, okay, which is placed in a glass jar. When it is connected, the reaction takes place when it's connected to the current. Okay, next what they have asked, they have asked us to calculate the EMF of the cell. EMF they have told us to calculate. Okay, so before calculating the EMF, first we'll see what reaction is taking place. This is the cell representation which is given over here. Okay, right. So in the representation, what you can observe, magnesium is undergoing oxidation and nickel is undergoing reduction, right? Okay, so half cell reaction, we have written the oxidation of magnesium, anode oxidation is taking place, and the cathode reduction is taking place. Okay, and then nickel reduction is taking place, cathode. So this is the overall reaction. Okay, now for us to calculate the EMF of the cell, E naught cell is required, right? So in E naught cell is equals to E naught of cathode minus E naught of anode, right? E naught of cathode is minus 0.25 volt. Here it is given. Okay, magnesium is your anode and nickel is your cathode. Okay, so E naught of cathode is minus 0.25 volt minus 2.37. So when you calculate, you will get 2.12 volt. Next is E cell is equals to E naught cell. Just to calculate the EMF, this is the formula. E cell equals to E naught cell minus 0.0592 upon N. N is the number of electrons to log of concentration of magnesium upon nickel. Okay, magnesium is the one which is undergoing oxidation. That should come at the top, divided by the nickel which is undergoing reduction. Okay, just substitute the values, and I have just taken this 10 to the power minus 4. See, here it is nickel is 0.0001. So I have just shifted the point, so it will come to 1 into 10 to the power minus 4, and when you shift this, it will come to 1 into 10 to the power minus 3. So that we have written over here. Okay, then I have taken this 10 to the power minus 4 on the top, so it will become plus 4. Calculate, you will get log of 10. Log of 10 is 1, and once you calculate everything, you will get this, which is 2.0905 volt. Okay, so let's move to the next question. What is the question? The cell in which of the following reaction occurs? Means the reaction is given. E naught cell value is given, which is 0.26 volt at temperature 298 Kelvin. They told us to calculate the Gibbs free energy, that is delta G naught, and equilibrium constant Kc of the cell, of the given cell reaction. Okay. So the cell reaction which they are given is 2 Ag plus 2 iodine, 2 molecules of iodine gives 2 Ag plus iodine. Okay, the same reaction here it is. This is that reaction. Okay, I have written the half reactions first and then I have written the final reaction. Okay. See, so this is the oxidation. Iodine undergoes oxidation from minus 1 to 0. This is undergoing oxidation, and Ag plus to 0. So this is undergoing reduction. Okay. So this is the overall reaction. This is a half cell reaction. Oxidation occurs at the anode, reduction occurs at the cathode. This is the first step. After that, what they have told, calculate the Gibbs free energy. That is delta G naught. Okay. Delta G naught is what? Minus, formula for Gibbs free energy is minus NF E naught cell. N is the number of electrons transferred. 2 electrons are transferred. So here 2. Okay. And Faraday's constant is 96500 into the given E naught cell value is 0.26 volt. So all that you will get this answer in terms with respect to kilojoule per mole. Okay. Then they have asked us to calculate the equilibrium constant, which is Kc. Log Kc, temperature is there. Okay. And delta G naught value is there. Then we just have to substitute. This is the formula. Log Kc equals to delta G naught minus delta G naught upon 2.303 RT. R is your gas constant, T is your temperature. Just substitute the values. Minus and minus, this both answers are minus, minus, minus will become plus. When you solve this, you will get 8.79 answer. 8.79 log Kc. So you have to convert that log. You have to get the value of Kc. So what we will do, we will take antilog on both the sides. Log and antilog get cancelled. So this side will be antilog over here. So we have to find the antilog of that. This is a simple method. If it is your choice, whichever way method you want, you can calculate. 8.79, you have to calculate the antilog of 8.79. You can split and write it like this. 8 plus antilog of 8 plus antilog of 0.79. Okay. Antilog of 8 is 10 raised to the power 8. Antilog of 0.79. Using the log table, you have to calculate. You will get 6166. Final answer is 6.166 into 10 raised to the power 8. Answer Kc. Okay. Let's start with the next question. They told us to draw the neat label diagram of a lead storage cell. This is the lead storage cell. which is having two different types of electrodes, which is PbO2 plates and lead plates. Okay, PB plates. PB plates is your anode. This side it is connected. This is your anode, and PbO2 plates is your cathode. And in the electrolyte solution is aqueous H2SO4. So this is a diagram of lead storage cell, and they have asked us to solve a problem to calculate the equilibrium constant of the cell. And this is the cell. In this given cell representation, it shows that zinc is undergoing oxidation and copper is undergoing reduction. Okay, these are the values which are given. E0 cell, Faraday's constant, and temperature is given. Okay, you have to calculate the log Kc. Equilibrium constant you have to calculate. Okay, just substitute the value of E0 cell, R, T, N. N is number of electrons transferred, which is 2 electrons. Okay, and just solve this. Substitute the values. Solve. You will get this. Here, just shift the point. If you shift the point, you will get this 10 raised to the power minus 2. Okay. Same method. If you shift the points, you will get this, and approximate answer is this 1 into 0, 1 into 10 raised to the power 1 log Kc. Then take antilog on both the sides. When you take antilog on both the sides, this log and antilog gets cancelled. You have to find the antilog of 10. Okay, so antilog of 10 is 1 into 10 raised to the power 10, means 10 raised to the power 10. So answer is 1 into 10 raised to the power 10 Kc. So answer is yes. Let's go with the next question. They have asked us to calculate the EMF of the cell, given cell, and the E0 cell or E0 of cathode and anode is given. Okay, we just have to calculate the EMF of the cell. E0 of this is that reaction of that they have given the cell representation in which iron is undergoing oxidation and silver is undergoing reduction. So that half reactions I have written over here. This is the overall reaction. This is undergoing oxidation. So this is anode and this is cathode. Then you first to calculate the EMF, this is the formula. So you have to calculate the E0 cell. E0 cell is equals to E0 of cathode minus anode. So E0 of cathode is 0.80. This is your cathode which are undergoing reduction. Cathode minus your anode. And it's minus plus, you will get 1.24 volt is the E0 cell. Substitute the values in this formula. Okay, 1.24, you will get this. Concentration of this is given as 10 raised to the power minus 4. Of iron is 10 raised to the power minus 4, which is given, mentioned in the question. Okay. And upon this Ag concentration is 0.1 raised to the power 2. Because here there is 2 molecules of Ag, right? 2, that's why here raised to the power 2. Okay, then you have to, when I multiply 0.1 into 0.1, I'll get 0.01. Then this I have shifted the point, I have written it as 1 into 10 raised to the power minus 2. When the 10 raised to the power minus 2 I take it on the top, it will become plus 2. And solve, you will get 10 raised to the power minus 2. Log of 0.10 raised to the power minus 2. Minus 2 means 0.01. So log of 0.01 is minus 2. And then just solve this full part. Then minus minus plus or multiply this, you will get this answer. Answer is 1.299 volt. Okay, let's start with the next question. What is the question? They have given a reaction. Okay, and then they have asked us to calculate the Gibbs free energy change and equilibrium constant for the above reaction. Okay, and they have given the values of E0 of cathode and E0 of anode and Faraday's constant. Okay, so the reaction which they have given, half reactions of the given, this is the given reaction. I have written the half reaction of that. Okay, why I have written this is to know how many electrons are involved in this, because we require number of electrons in this to calculate the Gibbs free energy. Okay, so they told us to calculate the Gibbs free energy. What is the formula for Gibbs free energy? Delta G naught is equals to minus NF E0 cell. Okay, so from here we came to know that we require 6 electrons. So substitute in place of N, substitute 6 into the value of Faraday's constant 96500 into the E0 cell. Calculation of E0 cell, these values have been already given in the question. Values of E0 of cathode and E0 of anode is already mentioned in the question. You just have to substitute and find the E0 cell. Substitute the value of E naught cell in this equation, then you will find the answer. You will get the value of Gibbs free energy. Once you get the value of Gibbs free energy, you have to calculate equilibrium constant. Equilibrium constant is Kc. Okay, this is the formula for that. Log Kc equals to minus delta G naught upon 2.303 RT. Okay, the value, whatever value you are getting here is in negative, no? Delta G naught value is in negative joules per mole. The same value I have mentioned here, minus minus will become plus. Substitute the other values of value of RT, okay, 8.314 into 298 temperature, and then solve. Then what you will get, log Kc is equals to 34.500. Now we want the value of Kc. So what you are going to do, you have to convert the log. Means we don't want this log, you have to remove this log. So to remove this log, and you have to take anti-log on both the sides. When you take anti-log on both the sides, this log, anti-log gets cancelled. So what will happen here, it will be anti-log. So you have to find the anti-log of this. So calculate the anti-log of this, you will get this answer 3.16 into 10 raised to the power 34. Okay, that's the answer. Yes. Okay, let's start with the next question. Let's see what they have asked. They have asked, first question, they have asked, when a piece of a copper wire is immersed in a solution of silver nitrate, the solution becomes blue, represent the redox change in the form of a balanced ionic reaction. Okay, so they have asked why when you place a copper wire in a silver nitrate solution, the solution turns blue. So what exactly is happening? What reaction is taking place? Because of that it is turning blue, they have asked. So Ag, another solution, will contain what? Ag plus and NO3 minus ions, right? Yeah. So in that solution, when we add copper, what will happen? Reaction will take place between the silver nitrate and the copper wire and the copper metal. So what will happen? The copper wire undergoes oxidation. Copper is getting oxidized. Because of that, it means it is reacting. No, it is more reactive. When you see the reactivity series, copper is more reactive than silver. So copper is reacting with those ions. It is reacting and undergoing oxidation. Okay. So this is they have asked to write the reaction, ionic reaction, balanced reaction. So this redox reaction is taking place in the solution. Whatever, when you add the copper wire and the AgNO3, this reaction is occurring in the solution. What is happening? Copper is undergoing oxidation. So Cu will become Cu2 plus. There's 2 electrons. Then silver is undergoing reduction. Okay, silver undergoing reduction. It is reduced from plus 1 to 0, and copper is getting oxidized from plus 0 to plus 2. Okay, and this is the overall reaction. Okay, so because of that, since copper is undergoing oxidation, the solution is turning blue. Okay, the next question what they have asked is just a minute. Okay, they have asked, can an aluminium coating on an iron act as a sacrificial anode in protecting the iron against the corrosion? They are asking that aluminium coating which is made on the iron, no metal, all these everywhere you can see corrosion, no? So we prevent the corrosion by different methods like painting, galvanizing. There are different methods. Here one of the method is they are coated, aluminium coating is done on the iron to prevent its corrosion. They have asked, it can act as a sacrificial anode, it can protect. Yeah, if it is so, why? Give reason how it protects and all. They have asked. Okay. Then yes, aluminium protects the iron from corrosion. How? Yes, see, because when you go through the standard reduction potentials of aluminium and iron, which is mentioned in the question, the standard reduction potential of aluminium and iron, aluminium is having a more negative reduction potential and iron is having less. See, minus 0.44 is of iron and aluminium is minus 1.66 volt. Okay. So aluminium is having greater negative reduction potential, and it is also more reactive than iron. Aluminium is more reactive than iron. Okay, because of that, aluminium undergoes reaction. It undergoes oxidation. It will oxidize faster than the iron. So first it is on the outer layer. It will get oxidized first. It will protect the inside iron. It will protect. So as a result, aluminium corrodes instead of an iron. Okay, that's why when you do a coating of a aluminium metal on the iron, it protects the iron from getting corroded. Okay, because it is more reactive and aluminium is more reactive than iron, and it is having a greater negative standard reduction potential. So yes, that's what is the answer for that. Okay, we'll start with the next question. It is very simple. They just asked now how many number of electrons are involved in this reaction. Okay, so the reaction is given, only this number of electrons you are supposed to write. Okay, MnO2 plus 4H plus, see, magnesium, Mn is undergoing what? Plus 2, 0 plus 2 oxidation state. So, the number of electrons will be 2 electrons. Will be 2 electrons, and Ag, it is very familiar, well known reaction, Ag plus to 0. So, one electron is being lost. That's it. Okay, let's go ahead with the last question of this chapter. They've asked state Coriolis law. Explain with an example. This is your first question. And then they have asked one small numerical based on this Coriolis law. Okay. So first we'll see what is this Coriolis law states. It states that the limiting molar conductivity of an electrolyte is represented by their individual concentrations. Now see, example is this sodium chloride. Now, limiting molar conductivity of that particular electrolyte is explained by each concentration of each individual ion, of concentration of anion and concentration of cation. Okay, so in example is C. Example is NaCl. And the limiting molar conductivity of a NaCl solution will be concentration of the anions, that is Na plus ions, and concentration of Cl minus ions. Okay, so it is represented in this way. The limiting molar conductivity of NaCl is represented like this. The conductivity of anions and cations and anions, Na plus and Cl plus. So that is what the Coriolis law states. It is a sum of the individual concentration, sum of the concentration of anion and cation. That is what is Coriolis law. Okay, so based on that, they have asked one question. They have told us to calculate the molar conductivity of HAC. Okay, one which is not given here. Okay, limiting molar conductivity lambda not m. This is a symbol for that. This is capital lambda. This inverted V. It is a symbol for capital. It is a capital lambda represents the molar conductivity of the solution. So they have asked us to calculate the molar conductivity of HAC. They have given in the question, it is mentioned, they have given the limiting molar conductivity of HCl, NaCl and NaCl. This one we have to find out. So whatever values they have given, I just have to substitute. This is the formula for that. Plus, minus, these two molar conductivity you have to add, and this minus. This is a formula for that. You just have to substitute the given values, then solve, and you will get the value of molar conductivity of HAC is 390.5 centimeter square mole inverse. Similar type of questions will be asked based on this Coriolis law. Thank you. Thank you for watching the video. Please like, share and subscribe Buddhi Academy. Thank you.